Hi everyone, I am Dr. Siva Kumar, CSE Department, VNR VJEC. Today I am going to explain what is stack data structure. So before we are going to see what stack data structure, first we will see what do you mean by data structure and what is the importance of the data structure. So simply we can define a data structure is a specific way of organizing and sorting data in a computer so that it can be accessed, managed and used efficiently. So why we require this data structure means, so this is the importance. We can effectively use the memory and we can fast access the data from the memory and we can do the problem solving effectively and we can reuse the data from the memory. So these are the important why we require the data structures is. So we can divide the data structures into two categories. So linear data structure and non-linear data structure. So again this linear data structures we are having static data structure and dynamic data structure. And for non-linear data structure we are having two, that is tree and graph. So what exactly the meaning of linear data structure? So linear data structure means if you are able to arrange the data in sequence manner. So there it is called linear data structure. So we are using some example for linear data structure is arrays, stacks, queues and linked list. And we can implement these stacks and queues either by using arrays concept or linked list concept. But we can also say array is static data structure because we are already known about array, how exactly the data can be stored and how we are retrieving the data and what are the operations we can do. And we are going to learn about stack data structure, queue data structure and how exactly the linked list will be implemented. And coming to the nonlinear data structure, here the data will not stored in the sequence manner. So here we are connecting all the data wherever the data is present in hierarchical way, and we are using two data structure models here, that is tree and graph. Today we are going to elaborately discuss about stack data structure. So what do you mean by stack? So stack is nothing but it is a linear data structure and which can follow the LIFO order, that is last in first out order. That means, for example, this is a stack. So if you are taking this stack, the data will be inserted. So here the insertion operation we are going to call as push operation. And whatever the data I can push into the stack, that can be stored like this. So first data will be stored here. On top of first data, the second data will be stored. On top of second data, the third element will be stored. And whenever you are removing some data from the stack, so it is called pop operation. So here whatever the data we are removing from the stack, that operation is called pop. And whenever I am doing the pop operation, it is going to remove the top element of the stack. So that's why it is called LIFO order, last in first out. So whatever the last inserted data in the stack, that can be removed first when you are calling the pop operation. So this is about linear data structure of stack. And these are the common operations we are executing on the stack. So that is push operation. Push is nothing but whenever you are inserting some element to the stack, it is called push operation. And whenever you are removing the data from the stack is called top operation. And we can use special variable called top. So this top represent how many elements are there in the stack. And we can also check whether the stack is empty or not by using the isEmpty function. And the size return, what is the size of the stack. So I will take one example and explain you how exactly the stack operation can be done. So per suppose I am having some stack. So this is the stack I am having with size m. The size m, that is size, for suppose I am taking size as 3. and this is the stack. And initially there is no data into the stack, and the top variable is called -1, and the index of stack is 0, 1, 2. So this is the initial state for the stack. The top variable is -1 and all the locations of the stack is free, and the size, maximum size of the stack is 3. For suppose if I am calling some push operation, I want to push some data, some 10 I want to push. So when I am pushing the data to the stack, first it is going to check whether is there any space available to insert the data. Yes, top is -1 representing, it is a empty stack and I have all the spaces, so I can easily push the data 10. So first I can increment top value as 1, -1 plus 1, it becomes 0, the index is 0, and the element will be inserted here, 10. So for suppose if I am calling one more operation, push some 20. So again it is going to check, yes, top will be incremented and check whether the space is available or not. Yes, now the top is 1 and space is available, and you are inserting the data 20 here. So this is how the push operation will do. Again I am pushing some data, some 30. So again top will be incremented. Yes, top becomes 2 now, and it is not full, and we have some space here, so I can able to push the next element into the stack, 30. Now I am pushing some more data, push 40. So top will be incremented and top value becomes 3. When top is reaching to the maximum, that means the stack is full and there is no empty space to insert new data. So we will stop over there and we can say stack is full. Stack is full, I cannot insert new data. In some other words, if we are saying stack is overflow, I can also say it is a stack is overflow. So in such cases, we cannot insert new data to the stack. We will stop insertion here. Next, now I am calling pop operation. So what is pop operation? Pop operation means it is going to remove data from the stack. So it is a stack data structure. Stack data structure means it is lost in first out. So whenever you are going to execute pop operation, first it is going to remove the top element of the stack. So what is the top element of the stack? 30. 30 will be removed from the stack and top value becomes 1. So I removed from here and this is empty. Now the top is indicating 1. So I removed one data from the stack. One space is available now. Right? Next, for suppose if we are calling again push some data 45. Again you can check. Yes, top becomes 2 now, and in index 2 the empty space is there, and now I can able to push 45. So that is how we can insert the data by using push operation. Now I will do all pop operations. Now I am popping the data from the stack. So it is going to decrement the top value to 1 and it is removing top element 45 from the stack. So top becomes 1 and this data is removed. When you are executing continuously, the next one pop. So again the top value becomes 0 and top element 20 will be removed from the stack. So now top is indicating this location. So when you are calling again pop operation, so it is going to decrement top as -1 and you are removing 10 and top value is indicating -1. So you are removing 10 from the stack. So now the top reaches to the -1 means the initial state of the stack. So where exactly the stack becomes empty. For suppose if we are again calling pop operation. So already the stack is empty, there is no data. Again if we are calling that pop operation, so it is going to say there is no data to pop out from the stack. So the stack is empty. Here the stack is empty, and we can also say the stack is underflow. Stack is underflow. So what do you mean by stack is underflow? The stack is empty and I cannot able to remove data from the stack. Right? So we will get two cases: stack underflow cases, stack overflow cases. So when you will get stack overflow, if the stack is filled with all elements. When you will get stack underflow, if all elements is removed and there is no data in the stack, that is empty stack. From empty stack, if you want to pop out some data, so there we are saying the stack status is underflow. So this is how exactly the stack operations will be done, and now I can explain you how we can implement these operations as a program. So in this program, I am taking a stack with size maximum of 3, and I am defining 3 functions here: push function, pop, and display. So initially I am taking the top value as -1, and the stack maximum size is stack of 3. Stack of 3 means the index will be take 0, 1, 2. Okay. Here I am defining the menu driven program. So here I am taking the switch case where I am taking for the different cases. The case 1 I am taking for the push operation, case 2 I am taking for the pop operation, and case 3 I am taking for the display. So this is the menu driven program I am writing by using switch case here. So what exactly the push operation already we seen in the example. So whenever you want to insert data to the stack, so first I want to check the condition. If top -1 equivalent to max, so already the top variable reaches to the maximum size of the stack, there is no free space to insert new data. So I can throw a message, the stack is overflow. Otherwise what I am doing, I am incrementing top value and I am assigning that value to the down. So what is the initial case for the top? Top is -1. So whenever you are saying top is -1, the stack is empty. The stack is empty. And what is the maximum size of your stack? The maximum size is 3. Already the top -1 equivalent top reaches to the max 3. So I can also rewrite this case as top equivalent to -1. So that is also true. So this is the 0, 1, 2. So what is the max -1? 2. If top is already there in the 2 also, it is full. So we can write this case, this condition in 2 ways. Either you can check top -1 equivalent to max, or you can also check top equivalent to max -1. So for already the data is filled up to here. So here the top -1 equivalent to max. So there is no free space to insert to the stack. So I can say it is the stack is overflow. Otherwise for empty stack, top is -1. First you can increment top value, so that is top equivalent to 0. Then you can insert the data, or you can increment top value and you can insert the data. You can increment top value, you can insert the data. So I can do this operation until the top is reaches to the max -1 into the stack. So this is push operation. Coming to the pop operation. So what is pop operation? To remove the data from the stack. So first I am checking if already the top value is -1. So it is empty stack. So when you will get the top is -1 when it is a empty stack. Initially the top is -1, so there is no data in the stack. So I can say the stack is under flow. The stack is under flow. Otherwise, what I'm doing, the top element of the stack, I'm going to, for suppose I'm having already 10, 20. So automatically top represent to 1. So here I'm storing x equal to stack of top. So what is x? Stack of top 20. Then I'm making top equal to top minus minus. So I can decrement the index of the top here, and I'm returning this value to the main by using pop operation. And I have a display function. So if you want to display all the elements, what are the elements I'm having in the stack? So I can use this display function. So if the top value indicate to -1, it is the initial state where the stack is empty. Where the stack is empty, so I am throwing the message stack is empty. Otherwise, so where exactly the top value represent the top element of the stack. For suppose 10, 20 is there, so there the top is 1. So I am going to display all the elements from top position to 0. So it is going to take for loop from top to 0. So I am going to print 20, 10 in the stack. So this is the function what I am using for the display. And here I am giving only 3 functions, that is push, pop and display. So this is how exactly we can write the code for the operations of the stack using arrays. So you can also implement with the different size of the array, and you can also check different operations here. And we can also define the stack with different data type. If you want to check with character array, you can define character array here, and we can define the stack with any data type here. So in this example, I am taking only integer array. So this is how simply we can implement the operations of stack: push, pop, display. I hope it is clear how exactly the stack operations we can implement by using arrays concept, and what is stack, and how exactly the data will be manipulated in the stack data structure. So it is very important. And coming to the applications, so where we can use these stack operations. So if you are effectively, if you want to use the memory, we are going to use stack data structure. So for example, if you want to reverse the data, so I can push all the data and I can pop out in reverse order. And we can also use recursion. To store all the recursive call, we can also use this stack data structure. And it is very important to implement stack data structure for conversion of the mathematical notation from infix to postfix or infix to prefix. And if you want to evaluate some postfix expression, that also we can use stack data structure here. So all these are the different examples, applications, where exactly we can use the stack data structures here. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.